How to make a one-digit number, which you choose, appear 6 times in a row, starting with an unrelated, arbitrary 3-digit number. First, take a one-digit number from 1 to 9. Remember it for later. Then take a 3-digit number, not ending in 0. First and last digits differ by at least 2. Ready? Here we go. Write down the 3-digit number. Then write down the 3-digit number with the digits in the reverse order. Subtract the smaller of these two numbers from the larger. Now you have still another 3-digit number. Write it down. Then write down the new 3-digit number with its digits in the reverse order. This time you don't subtract. You add these last two 3-digit numbers together. Remember the result. Take this new number. Divide it by 9. Remember the one-digit number you chose at the beginning? Multiply it by the remainder and add the product to the whole number part of the quotient. Take the resulting number. Add 22. Multiply the sum by the one-digit number you chose at the beginning. Here's where it gets fast and interesting. Multiply that result by 3, the product by 7, the product by 37, and there you have it, the original one-digit number 6 times in a row. Works every time. Keep watching, and I'll show you how it works. Here's how it works. Take a 3-digit number, the last digit not 0, and the first and last digits differing by at least 2. Let h equal the hundredths digit, t equal the tens digit, and u equal the units digit. Then the number itself is 100 times h, plus 10 times t, plus u. Reverse the digits, and that number is 100 times u, plus 10 times t, plus h. Choose which is switch, so that h is greater than u. Now subtract the smaller of these from the larger. You get 99 times h minus 99 times u, because the 10 times t cancels out. Now to reverse the digits. That's a little tricky. The hundreds place looks like h minus u. The tens place looks like 0. The ones place looks like u minus h, except you can't have a negative digit. Uh-oh, let's add 10 to the u minus h and subtract 1 from the tens place. Hold that thought. So far, the hundredths place looks like h minus u. The tens place looked like 0, except we just subtracted 1 from it, and that won't do. The ones place is 10 plus u minus h. And because h is bigger than u, and neither u nor h is 0, u minus h is between minus 2 and minus 8. Then we know for sure that the ones place makes sense. Getting back to the tens place, we can't have minus 1 as a digit, but we can add 10 and have 9 as a digit. So we know for sure that the tens place is a 9. But about that hundredths place, it turns out to be h minus u minus 1, with the 1 subtracted because of the tens place issue. Finally, we have the original number minus the reverse number. 100 times h minus u minus 1, plus 10 times 9, plus 10 minus h plus u. Now we're going to reverse the digits again and add. Fortunately, the algebra is much easier. Take this number that you figured out, 100 times h minus u minus 1, plus 10 times 9, plus 10 minus h plus u. Reverse the digits to get 100 times 10 minus h plus u, plus 10 times 9, plus h minus u minus 1. Then add them up. It looks like a mess, but it gets simple pretty quickly. 100 times h minus u minus 1, plus 10 times 9, plus 10 minus h plus u, added to 100 times 10 minus h plus u, plus 10 times 9, plus h minus u minus 1 is 100 times 10 plus h minus u minus 1 plus 90 plus 90 plus 10 minus h minus u minus 1. Better yet, the alphabet soup simplifies to 100 times 9 plus 180 plus 9. That's right. It is always 1089, regardless of the three-digit number you start with. 1089 is 11 times 11 times 9. This is important. 111,111 is our target. We want to sneak the one-digit number into the list of factors somehow, so it does not easily show. Then when the list of factors of 111,111 has the one-digit number added to the list, then you get that number repeated 6 times instead of 111,111. The prime factors of 111,111. 3, 7, 11, 13, and 37. So when we divide 1089 by 9, we get 121 with no remainder. We can multiply the remainder by any number we like and add it to the result. It's 0, remember? 121 equals 11 times 11. We need 11 times 13. So we add 11 times 2. That's why we add 22. Then we have 143, which is 11 times 13. Take the number 143, multiply it by a one-digit number, which I call n. Then you have 143 times n. But it is also 11 times 13 times n. Multiply that number by 3 times 7 times 37. And you have 3 times 7 times 11 times 13 times 37 times n, or 111,111 times n. And there you have it. The 6 digits repeated trick explained and proved.